Alright, so today we're doing coordinate notation and reflecting objects. That's the notes topic. We're going to start with some review of vocabulary, things that we've already talked about in class for some of you. For some of it, we haven't talked about much at all, but this is some vocab that's going to apply to transformations and reflections as we are starting right now. And we'll also have a little bit of review of some algebra things that we have down here at the bottom of this vocab section. Alright, so for the first one. For any transformation, the original object is called the pre-image. The picture before you've transformed it. Pre-image. For any transformation, the transformed object is called the image. When point A is reflected about a line, its image is A prime. We can name it another letter. We could name it X, W, whatever. But typically in class, you're going to see me use A for the original and A prime for the transformed. A reflection is an isometry. An isometry, that's a new word. Another way to name it is a rigid transformation. As I'm going through these, the bell is going to ring here at school, so you'll probably hear that in the background. This means that reflections preserve segment lengths and angle measures, and we know what the word preserve means, to keep it in its original form. So like if I reflect a triangle or a polygon or a figure of some sort, when I reflect it, I'm not going to change the segment lengths, I'm not going to change the angle measures. It's simply going to change the orientation or the placement of the object. It's not changing its size in any way, shape, or form. The next one. This is the definition of a reflection. So this is one of those definitions that we need to have. Now this definition has two parts. A reflection of a point P about a line M produces a point P prime. So that if P is on line M, if a point is on the line of reflection, then we know that that point stays in the same position. So P and P prime will be equal. They will have the same coordinates. If P is not on line M, then the line is the perpendicular bisector of the segment PP prime. Remember what perpendicular means. Perpendicular indicates that we have right angles formed, and bisector tells us that some segment has been intersected at its midpoint. So in this case, where the line and the segment connect will be the midpoint of that segment, creating two smaller segments that are congruent to one another. These last two are more algebra related. An equation of the form x equals a number is what type of line when graphed? We know that produces a vertical line. And a line of the equation y equals a number will become horizontal. Okay, so these are some basic vocab terms associated with transformations and reflections that we're going to be using both in these notes and throughout our study of transformations in general. Okay, so today we're also going to look at not only reflecting objects, but coordinate notation. So as we do that, let's talk about what coordinate notation is and how we write it. Alright, coordinate notation is a way to state how a set of points will be affected by a transformation without using words. And we're going to find that in mathematics, we do a lot with equations, we do a lot with symbols, and this is just another way that we're going to do that. The information that I'm going to get for this first column, how do the coordinates change, comes off the worksheet we did in class. So we did a worksheet where you had 6 points you were given, and you were given various lines that you had to fill in. It was a table. And then down below that table, there were 4 questions you had to answer, describing how the coordinates changed. That's where this is coming from. Okay, so a point is reflected in the x-axis. And we said from that paper that when you reflect a point in the x-axis, the x-coordinate stays the same. And the y-coordinate becomes its opposite. Now in terms of coordinate notation, we're talking about points and how points are changed. So I'm going to start with a point, x, y. X and y representing some positive or negative, some 0, some type of numbers. And we're going to describe how it's changed. Now we show a transformation using an arrow. So we start with an original point xy. It is transformed to, and this is where this last thing back here comes from. The x coordinate stays the same. So where I had an x, I'm going to have an x. The y coordinate becomes its opposite. So rather than y, I'm going to have the opposite of y. Now an example of what that would look like. Let's say we have the point 3, -2, and I want to transform it by reflecting it in the x-axis. That means the x coordinate will stay the same. It's going to stay a 3. And the y coordinate will become its opposite. So the opposite of -2 becomes +2. The next one, reflecting a point in the y-axis. And we said in the y-axis, that means the x coordinate becomes its opposite. And the y coordinate stays the same. Nothing's going to change in that aspect. So in terms of our points, we start with a point and transform it in the y-axis by changing the sign on x, but keeping y the same. So in this case, if we use that same point 3, -2, says use the opposite of your x, so the opposite of 3 becomes -3, and the y stays the same, -2. A point is reflected in the line y equals x. From our paper before, we said switch x and y. So a point xy switches the position of y and x. So y and x switch places. Start with that same point, 3, -2. Switch the positions of x and y. So -2, 3. And the last one. A point is reflected in the line y equals the opposite of x. We said in class that we would switch x and y. And change both to their opposites. So we're not only going to switch their position, but we're going to switch their sign as well. Okay, so think about it in terms of a point. We switch their positions, so xy would become yx, and then change their signs. So the opposite of y, opposite of x. One thing I do want you to get out of the habit of is calling it the negative of y or the negative of x. We want to use the term opposite. Okay, so we've got our point 3, -2. We switch their positions and switch their signs. So rather than a -2, we'll have a +2. And instead of a +3, we'll have a -3. Switch their position and switch their signs. Now, there's a note down here at the bottom of the page that describes that there are ways that you can write coordinate notation for other vertical and horizontal lines, like x equals 3 and y equals 2. But we're not going to be doing those. The only ones for reflections that you will have to be able to know in coordinate notation are the 4 that you see here. There aren't any other coordinate notations for reflections. There are for translations and rotations, but there won't be for reflections that you will be responsible for knowing. Okay, so we progress to the second page of our notes. We're going to start on this second page reflecting an object over a given line. You're given a polygon of some sort in each of these, and you're given a line of reflection. And there's 2 ways that you can do these. If the line of reflection is one of them off the table we just talked about, y equals x, y equals the opposite of x, the x-axis or the y-axis, then we can do it with coordinate notation. If a line is simply vertical or horizontal, then we'll do it by counting. I'm going to show you both here in number 1 and number 2 how that's going to work. Then I'll give you an opportunity to do 3 and 4 on your own and kind of check your work. I'll keep recording and put it on here on the video, but you can at least check your work and see how you're doing. All right, so the first thing I see in number 1, a reflection across the line y equals 2. Now, y equals 2 I know is a horizontal line. It's going to cross the y-axis at 2. And we don't have scale given here, but the scale on each of these diagrams in this packet, each box is 1 unit wide. So where y is 2 would be this line. Now this isn't one of those lines that I have a coordinate notation trick for, so this isn't one that I'm going to be worried about. When that happens, I'm simply going to count distances. I notice on this one that the 3 vertices of the triangle, L, X, and T, are all above my line of reflection. So when I reflect it, I know they're all going to end up below. I'm simply going to count how far away they are from the line and reflect their the X prime, L prime, T prime, the same distance away from that line, but below it. So since L is 1 unit above our line of reflection, L prime will be 1 unit below. Make sure you're labeling each point. X is 3 units above, so X prime will be 3 units below. T is 3 units above, so T prime will be 3 units below. And then go ahead and connect those to create our triangle. And that's the reflection that takes place in that case. Alright, so with number 2, I notice that the line of reflection is y equals the opposite of x. Since it's y equals the opposite of x, I know there's a coordinate notation that I can use for that. And that says we switch the position of x and y and change their sign. So I'm going to take each of these original points, S, L, and C, and I'm going to change their position, or change their coordinates by switching x and y and changing their sign. Alright, so S is the point 1, 1. L is at 3, 0. And C is at, let's see, 1, 2, 3, 4, 1, 2, 3, 4, 5, 4, 5. Okay, so for each one of these, to create S prime, L prime, and C prime, I want to switch the values of x and y, switch their positions, and switch their signs. So the 1, 1 switches to 1, 1, change their signs, -1, -1. Switch 3, 0 to 0, 3, change their signs, 0, -3. Switch 4, 5 to 5, 4, change their signs, -5, -4. Okay, so now I'm going to go ahead and actually plot those coordinates. And I'm plotting these 3 coordinates here. The original are already there, so we don't have to worry about those. So we have S prime at -1, -1. L prime at 0, -3. And C prime at -5, -4. And then go ahead and connect those to create the polygon. 1, 2, 3. Okay. Now, you go ahead and pause the video here and try numbers 3 and 4 on your own. I'll have the answers up in just a minute. And on to the last page. Alright, our last page. Some problems are going to ask you to describe a type of transformation that you see, whether it's a reflection, a rotation, or a translation. For each of these, we're going to draw in a line of reflection and describe a single transformation that will produce the image shown. If possible, write the coordinate notation of the reflection as well. Alright, so in each case here, some people can visually look at a diagram and determine where the line of reflection is. They can see the yellow, they can see that pinkish purple. But what if you can't? Then what do you do? So let's talk about how that works if you don't automatically see that result. Okay, so I'm going to go ahead and delete those. Let's look at the images. So we're given two images here, and each one, of course, has the points labeled with the U and the U prime. Oops, helps if I select the right tool here. U and U prime, N and N prime, and T prime. What I want to do is find the midpoint, because remember, the reflection is the perpendicular bisector. That line is the perpendicular bisector of the segment connecting the point and its transformed image. So in this case, if it's a bisector, it has to pass through the midpoint between those 2 points. So if I'm looking at U and U prime, U is at the point 3, 5. U prime is at the point 5, 3. If I want to do the midpoint, remember a midpoint is an average. So I'd average the x's, 3 plus 5 over 2, and average the y's, 5 plus 3 over 2. In that case, for U and U prime, the midpoint becomes 4, 4. Okay, so that's a point on the line of reflection. Now I do the same thing with T and T prime, finding the midpoint. Now on this one it's easier, I can see it. The midpoint between them will have to be in the center of this box. And I can do it yet again for our third point, N and N prime, and there again I'm going to recognize that that's going to fall in the middle of that box. Now what should happen is that all 3 of those points lie on the same line. If they are not on the same line, you've done something wrong. Please go back and find out what it is. Maybe it's just a mathematical error. Maybe it's otherwise. But in this case, I end up with a line through those 3 points. And I want to see which of those lines it looks like. Is it the line y equals x? Is it the line y equals negative x? Is it the x-axis? Is it the y-axis? What is it? Well, in this case, I can see it passes through the origin, and it has a slope that goes up 1 and over 1, up 1 and over 1. So it goes through the origin with a slope of 1. That tells me it's got to be the line y equals x. I do the same thing on number 7. By the way, I don't know where number 5 went. It just kind of disappeared, but either way. Alright, so I start with any 2 points, a point and its reflected point, and look for the midpoint between them. So here the middle point will be there. Midpoint between W and W prime would be in the center of this box. Now, if you don't know where the midpoint is, go back to this algebra way and do it like we did here with U and U prime. There is nothing wrong with showing that work. G to G prime, let's see. It goes 2, 3, 4, 1, 2, 3, 4. So half and half would be 2 and 2. Okay, so right there. Now I can see my line again. Let's go ahead and draw that line into position, like so. Put on my arrows. Okay, so my line of reflection again passes through the origin, has a slope of positive 1, so this will be the line y equals x. Now the directions also state, if possible, write the coordinate notation for that line of reflection. You only can do that if it's one of those 4 lines like we talked about on the first page. If it's the line y equals x, you can write coordinate notation. If it's y equals negative x, you can do coordinate notation. If it's the x-axis or the y-axis, you can do coordinate notation. So in this case, the coordinate notation for this particular line, y equals x, says you take each point x, y, and switch their positions. So y comma x. And since they both have the same line of reflection, we end up with the same coordinate notation as well. Alright, so I would advise you at this point to pause things, do 8 and 9 on your own, and then come back and check them. that's what you should end up with. All right, so that takes care of your homework for this evening. Finish those notes. If you need further practice on those, you can look up reflecting points or look up coordinate notation whenever you are like in a Google search box, and it should bring you to some websites. You can put in things like the word applet, A-P-P-L-E-T, might help you find some others, or worksheet. If you put that as part of your search term, that'll help you find some others as well. Or if you're having trouble finding any, just let me know and I can try to come up with some for you in class that you can practice with.